Hello everyone. Today we are going to see a problem based on deflection of trusses. In this problem, we need to find the horizontal deflection at D. Also, we need to find the vertical deflection at C. Area of all of the members is 600 millimeters square and the Young's modulus for all of the members is 2.05 into 10 power 8 kilonewton per meter square. Area is given in millimeters square. We have to convert that into meters square. We know that 1 millimeter is equal to 1 by 1000 meter. But here there is a square. So we have to divide 600 by 1000 into 1000. That is 10 power 3 into 10 power 3. In this way, for the area, we will get 6 into 10 power minus 4 meters square. We need to form this table. In the table, first we need to enter all of the members. Then we need to find the member forces, that is P. Before finding the member forces, we need to find the reactions. At A, there is a hinged support, so there will be two reactions. The vertical reaction VA and the horizontal reaction HA. In the point D, there is a roller support. We know that in the roller support, there will be only one reaction. Here, there is only vertical reaction, that is VD. To find VA, I am going to take moment about D. In this case, we have to follow right hand side rule. Clockwise will be positive and anti-clockwise will be negative. VA is acting in the clockwise direction, so it will be positive, and the distance is 5 plus 5 plus 5, so it will be 15 VA. This load is acting in the anti-clockwise direction, so it will be negative, and the distance is 10. This load is also acting in the anti-clockwise direction, so it is also negative, and the distance is 5. This horizontal load is acting in the clockwise direction, so it will be positive and the distance is 4. For VA, we will get 12 kilonewton. Let us apply this rule and find VD. VA and VD are acting upwards, so both of them are positive. These two loads are acting downwards, so both of them are negative. For VD, we will get 16 kilonewton. Using this rule, we can find HA. HA is acting towards the left side, so it will be negative. This load is acting towards the right side, so it will be positive. For HA, we will get 10 kilonewton. Now we need to find the member forces. Before that, we need to find the angles. Let us take this triangle. In this triangle, let us find the angle theta. Tan theta is opposite side by adjacent side. The opposite side is 4 meter and the adjacent side is 5 meter. So it will be 4 upon 5. So theta will be 38.66. If this angle is 38.66, this angle and this angle also should be 38.66. First, I am going to take joint D and find the member forces. I am going to use method of joints to find the member forces. Similar kind of statically determinate structure I have already analyzed. This is in the description. You can see that for getting more idea in method of joints. Also, I am going to use only cos theta. If you wanted to use sin theta as well, you can do that. 90 minus 38.66, we will get this angle 51.34. In the joint D, first we have to use this rule because there will be only one unknown. This is acting upwards, so it will be positive. FDE is inclined. We have to resolve it in the vertical direction. To make it vertical, we need 51.34 degree. So with FDE, we have to multiply cos 51.34. It is acting upwards, so it will be positive. For FDE, we will get minus 25.61. Let us apply this rule and find FCD. FCD is acting towards the left side, so it will be negative. FDE is inclined. We have to resolve that in the horizontal direction. To make it horizontal, we need 38.66 degree. So with the FDE, we have to multiply cos 38.66. It will be acting towards the left side, so it will be negative. Just before we have found FDE, we can apply that. Negative into negative, it will become positive. For FZD, we will get 20 kilonewton. Now we are going to take the joint E and to find the member forces. If this angle is 38.66, this angle also should be 38.66, and this angle will be 90 minus 38.66. It will be 51.34. First, we have to use this rule because there will be only one unknown. This is acting downwards, so it will be negative. FDE is inclined, we have to make it vertical. To make it vertical, we need this angle. So with FDE, we have to multiply cos 51.34. Since it is acting downwards, it will be negative. We can apply the value of FDE. Already here there is negative and this is also negative. So negative into negative, it will become positive. FCE is acting downwards, so it will be negative. For FCE, we will get a 4. Then we have to apply the rule sigma h is equal to 0. This is acting towards the left side, so it will be negative. We have to make FDE horizontal. To keep it horizontal, we need this angle. So we have to multiply cos 38.66 with the FDE. It will be acting towards the right side, so it will be positive. FDE is a negative 25.61. We can apply that. For FEF, we will get minus 20. Now let us take the joint C. If this angle is 38.66, this angle will be 90 minus 38.66. It will be 51.34. First, we have to apply the rule sigma V is equal to 0. FCF is inclined. We have to resolve it in the vertical direction. To keep it vertical, we need this angle. So with the FCF, we have to multiply cos 51.34. Since it is acting upwards, so it will be positive. FCE is acting upwards, so it will be positive. Just before we have calculated FCE, we can apply that. For FCF, we will get this. Now let us apply this rule. FCD is acting towards the right side, so it will be positive. FBC is acting towards the left side, so it will be negative. FCF is inclined. We have to resolve that in the horizontal direction. To keep it horizontal, we need this angle. So with the FCF, we have to multiply cos 38.66. Since it is acting towards the left side, it will be negative. We can apply the value of FCF. Here already there is negative. So negative into negative, it will become positive. And let us apply the value of FCD. For FBC, we will get 25 kilonewton. Now let us take the joint B. In the vertical direction, we have only one member FBF, so that will be 0. Let us apply this rule. This is acting towards the left side, so it will be negative, and this is acting towards the right side, so it will be positive. For FAB, we will get 25. Now we are going to take the joint A. FAB we have already found. We have to only find FAF. Using this rule, we can find that this is acting upwards, so it will be positive. FAF is inclined. We have to resolve that in the vertical direction. To keep it vertical, we need 51.34 degree. So we have to multiply FAF with the cos 51.34. Since it is acting upwards, it will be positive. For FAF, we will get minus 19.21. Let us enter all of the values of P. Now we are going to find the values of K. First, I am going to find the horizontal deflection at D. To find the values of K, we have to remove all of the loads and to apply unit load at D in the horizontal direction. Because we are going to find the horizontal deflection, that is why we are applying the unit load in the horizontal direction. You can see that I have removed all of the loads and applied unit load in the horizontal direction. I have kept the unit load towards the right side because I assume that the horizontal deflection occurs towards the right side. Suppose if I get a negative value, that means the assumption is incorrect. Then I have to change the direction towards the left side. We need to find these three reactions. By applying this rule, for HA, we will get 1. To find VA, we can take a moment about D. VA is acting in the clockwise direction, so it will be positive, and the distance is 15, so 15 VA. For this horizontal reaction, there is no perpendicular distance about D, so we should not consider that. In this case, there is nothing, so VA will be 0. Using this rule, we can find VD. Otherwise, we can take directly VD as 0 because there is no vertical load or vertical reaction. In this case, VD will become 0. Let us take the joint D and find the member forces. Let us use this rule. We will come to know that FDE will be 0. Otherwise, you can apply shortcut. These shortcuts, as I told you already, I have made a separate video. You can click the link and watch that video. Let us apply this rule. This force is acting towards the right side, so it will be positive. FCD is acting towards the left side, it should be negative. For FCD, we will get 1. If FCD is 1, FAB also should be 1. If this is 0, this also will be 0. We can take the joint B and apply the rule sigma V is equal to 0. There is only one vertical member, that is FBE, so that will be 0. Then we can take the joint E. We can apply the rule sigma H is equal to 0. This is already 0, so FFE will be 0. And when we apply the rule sigma V is equal to 0, FCE is also 0. Then we can take the joint C. We can apply the rule sigma V is equal to 0. This is 0, so this also should be 0 because there is no other vertical force. Now let us take the joint C and find the member force FCB. We can apply this rule. FCD is acting towards the right side, so it will be positive. FBC is acting towards the left side, so it will be negative. We already know FCD 1, we can apply that. In this way, for FBC, we will get 1. Let us apply all of the values of K. Now we need to find the length of all of the members. Length of AB, BC, CD and FE is 5 meter. Length of BF and CE is 4 meter. To find the length of AF, CF and DE, we can use Pythagoras theorem, that is root of 5 square plus 4 square. We will get 6.403 meter. Then we have to find pKl. We need to multiply P with L and K. After multiplying, we will get these. We have to add all of the pKl so that we will get 350. The formula to find the deflection is summation of pKl upon AE. In this problem, the area and Young's modulus for all of the members are same. We can apply them and we can apply summation of pKl. For delta L, we will get a positive value. That means the assumed direction is correct. The horizontal deflection at D occurs towards the right side. With this, we can multiply 1000 so that we will get the horizontal deflection at D in millimeter. Now we are going to find the vertical deflection at C. We need to remove all of the loads from the truss and we have to apply unit load in the vertical direction. I have applied the unit load downwards because I assume that the vertical deflection occurs downwards. Suppose if I get a negative value, that means that my assumption is incorrect. The deflection actually occurs upwards. We need to find these three reactions. To find VA, I'm going to take moment about D. VA is acting in the clockwise direction, so it will be positive and the distance is 15. So 15 VA. The unit load is acting in the anti-clockwise direction, so it will be negative and the distance is 5. For VA, we will get 0.333. By applying this rule, we can find VD. For that, we will get 0.667. By applying this rule, we can find HA. There is no other horizontal reaction and horizontal load. In this case, HA will be 0. Now we are going to find the member forces. First, I am going to take the joint D and to find the member forces. First, we have to apply this rule because there will be only one unknown. This is acting upwards, so it will be positive. We have to resolve FDE in the vertical direction. To keep it vertical, we need this angle. So with the FDE, we have to multiply cos 51.34. Since it is acting upwards, it will be positive. For FDE, we will get minus 1.067. Then we have to apply this rule. FCD is acting towards the left side, so it will be negative. We have to resolve FDE in the horizontal direction. To keep it horizontal, we need this angle. So with the cos 38.66, we have to multiply FDE. It will be acting towards the left side, so it will be negative. FDE just before we have calculated, we can apply that. Negative into negative, it will become positive. For FCD, we will get 0.833. Now let us take the joint E and to find the member forces. First, we have to apply this rule. We have to resolve FDE in the vertical direction. To keep it vertical, we need this angle. So with the FDE, we have to multiply cos 51.34. It is acting downwards, so it will be negative. FCE is acting downwards, so it is also negative. We have already calculated FDE. We can apply that. Here there is already a negative sign. So negative into negative, it will become positive. For FCE, we will get 0.666. Then we need to apply this rule. We have to resolve FDE in the horizontal direction. To keep it horizontal, we need this angle. So with the FDE, we have to multiply cos 38.66. It is acting towards the right side, so it will be positive. FEF is acting towards the left side, so it will be negative. FDE is minus 1.067. We can apply that. Finally, for FEF, we will get minus 0.833. Now let us take the joint C. First, we have to apply this rule. FCE is acting upwards, so it will be positive. The unit load is acting downwards, so it will be negative. We have to resolve FCF in the vertical direction. To keep it vertical, we need this angle. So with the FCF, we have to multiply cos 51.34. It is acting upwards, so it will be positive. FCE, we have already calculated. We can apply that. For FCF, we will get 0.534. Then we have to apply this rule. FBC is acting towards the left side, so it will be negative. And FCD is acting towards the right side, so it will be positive. We have to resolve FCF in the horizontal direction. To keep it horizontal, we need 38.66. So with the FCF, we have to multiply cos 38.66. It is acting towards the left side, so it will be negative. FCF just before we have calculated, we can apply that. Also, we have found FCD, we can apply that. Finally, for FBC, we will get 0.416. Now let us take joint B and to find the member forces. When we apply this rule for FBF, we will get 0. Let us apply this rule. FAB is acting towards the left side, so it will be negative. FBC is acting towards the right side, so it will be positive. We can apply the value of FBC. Finally, for FAB, we will get 0.416. Now let us take the joint A. We have already calculated FAB. We have to only find FAF. Let us apply this rule and find FAF. This is acting upwards, so it will be positive. We have to resolve FAF in the vertical direction. To keep it vertical, we need this angle. So with the FAF, we have to multiply cos 51.34. It is acting upwards, so it will be positive. For FAF, we will get minus 0.533. We have already calculated the values of P and all of the lengths. we need to only apply K. Let us apply them. Then we have to find pKl. Then we have to add all of the pKl values. We will get 499.9. We can round this as 500. In this one, we can apply summation of pKl and area and Young's modulus. We will get a positive value. That means our assumption is correct. The vertical deflection at C occurs downwards. With this, we can multiply 1000 so that we will get the deflection in millimeter. Now we are going to end this session. Thank you for watching this video.